Um, hi, this is lecture for Friday. Um, is a reduced lecture. Well, it's 2 o'clock. There'll be 20 minutes left. But I was just talking for 10 minutes about how the projects get graded. And I was also talking about if you're really confused, like you've never done Unity before, you just don't know how to scope yourself, come email me. I'll sit down and talk with you. The worst thing you can do is just not say anything, just hide. Because even if you're afraid to talk in front of other students, you can at least make a personal appointment with me and we can talk. All right. So, yes, our first batch of projects is due October 8th with a lot of feedback and just deliver something. And it's your quality of your work based on your peers and how they're doing that your grade is going to be based on. And then lecture video from it's not, no, from 2 days ago, from Wednesdays up. My schedule is a bit of flux where a lot of meetings have changed around. So I have to, this day was an exception. I'd never be like 45 minutes late, but I might have to do something where we start the lectures at 1:30. But let me actually go into next week and let me see how the meetings lay, and then I'll see if maybe Wednesdays or Fridays might be reduced or class or something. But I'll let you know. Um, so for just the remaining 20 minutes, what I really wanted to cover is wrap up. Like I talked a lot about meshes and the mesh render, and I realized um, we need to spend a lot more time on that. So since we're talking about the gun assets, um, I'm just going to keep working on these ideas of guns, but keep picking apart more and more parts of it, and in particular the mesh. So since I just want to go. I think it was the disk disk range. So my explanation of what was happening here was not right. It was not just this one VFX. I realized at the end that there's a few others underneath here. So let me just wrap up talking about this VFX for this is when it's like that grenade launcher, plasma launcher. In this, the projectile VFX, which is different, terminates somewhere. It's moving across the room. It hits a wall. It hits a floor. The projectile VFX or prefab gets destroyed in this explosion, which disk range isn't the best name for it, but this gets instantiated and it plays. So if we look at the top, so the root, so it's common when you have a very complicated prefab or nested game object that there's many parts to it. It's very common to have just a root object at the top that just has a transform and it may have like a basic controller script at the root. But the root is usually controlled, like the movement, the position, rotation, scale, the whole transform of it is usually controlled by code, whether by the game manager, the player manager, or whatever's happening that this gun system is controlling it. But notice that at the root is just a transform. So underneath it, actually, I'm going to turn off the rest of these. I realize that you can just see one at a time. So the top one is just this. And resimulate. I'm seeing if I can speed range. All right. So let me move down here. One thing to note is how many it's showing how many particles and how long their speed is. So you notice we just have one. And if you remember, it was that big mesh. So there's this wireframe material, and it's just being displayed on this mesh, and it's this platonic mesh, this kind of soccer ball object. And I'll talk. I'm going to hold off talking about meshes a little bit more for right now, but it's basically just rendering this one mesh, and it expands out and it disappears. And if you look at this VFX system here, it's running for 2 seconds. There's just a slight delay, like 100th of a second, and then it starts. The lifetime is like 1/3 of a second, and then it goes away. And the start size is 5 units, and then that's really just compared to like whatever's that's like 5 meters. So you kind of scale your stuff based on the global system, how big stuff is up here. Usually it's life size. In this case, a 5-meter explosion is like 15 feet. A meter is like 3 feet. So play on awake, it doesn't wait to get started. You don't need to execute it with code. It just, you turn this on and it plays. And so the emission here is just, it emits one thing in one cycle, and that's it. So you can have much more complicated, like different bursts with different probabilities of them happening. In this case, it's just one. The shape, in this case, I don't think that this, again, the shape of the emitter, the emitting volume. And since this object just comes in the center of the world of its local world of the emitter, I don't think the shape would even matter, whichever one you put on it. So limit the velocity over lifetime. All right, so this says that we have a speed of 1, it's like 1 meter per second, a dampening effect, which means it slows down. A dampening is like air resistance. If you're moving through water, it acts as like a deacceleration on whatever the initial speed is, and the same with the drag here. So if you notice, it kind of slows down. It's like popping and it stops right there. So the color over lifetime looks like it's just fading. So again, the green, the color characteristics are coming from this. See here, the albedo of the green. Let's try and change it to blue. Let's see what happens. So now you got a blue explosion. And you can change it to red. But it starts off at a half transparency. That's what this little thing, so notice the alpha underneath here. So we can ramp this up and be like, no, fully red when we start. And it will go to 0 alpha at its end. And so that's up here, color over lifetime. So when it's white like this, it means it's not adding any color to the initial start color. So color mixing can be really weird. And there's like multiple areas where you can impact the color. So just know it's saying like whatever the original color is, keep it there and then fade to 0, fade to an alpha. That's what the checker pattern here is representing. Size over lifetime. So this is that scaling effect. If you notice here, it's represented as a graph, a 2D graph, going from 0 to 1 with a nice curve on it. So if I move this and maybe I'll do like a hump. They say go up to 1 and then go back to 0. Let's click play. So notice it goes to full, whatever the full size of the mesh was, and then it bounces back. We could do a reverse. We could say, hey, let's start at 1. Let's keep it like this. This will ramp up from 1 to like 1.5. I can't scale out. And then down to almost like a 0. So it looks like it's really big and then it gets really small. So let me try and get that. Problem right now is my handles going off screen. Let me move it down. So these handles are called Bezier handles. And they create what's called a Bezier curve. You'll see them a lot in animation. So instead of like a linear curve, so a linear curve would be something like this, where the numbers translate from 1 to 0, in this case, 1 to 0 over the lifetime. And it's a very like flat animation. There's no like liveliness to it. Sometimes you do want flat movements. Sometimes you want stuff that's very curvy. So there's this whole theory of animation that came from Disney, and there's like squash and stretch, and there's spring, and there's like anyway, these different animation curves which give a feel of like momentum and movement, size and weight. So just know like that's what you're doing is basically you want to think about your initial starting point. In this case, you're saying I want to start from a scale of 0, and I want to ramp up to a scale of 1, but I want to do it in like a robotic mechanical way. I want to go in like linear speed, like as we interpolate the values from 0 to 1, they all have a fixed change between them, a fixed delta. Or I want, this would be like a slow ramp up. Let's stay at 0 for quite a while, and then this like ramp up to 1 really fast at the end. So you have to keep playing it over and over and changing it. and get a sense for like, oh, what are you trying to convey? What's the emotion? What's the feel? What are you trying? What part of reality are you trying to recreate? And that's what you try to achieve with the change of colors and the speeds and what have you. And in this case, that's it for this VFX. So that was this outer shell or cage. Um, and so bit by bit, I'll turn on the others and click play. And so here is the shrapnel. So if I turn off, unfortunately, I can't just turn off the particle system. I can if I turn off the game object, it'll turn off all the children. So what I can do is, oh, it's I don't think it's that distracting. I just don't want you to look at the big circle thing. So these are the shrapnel pieces. It looks like it's just duplicated for shrapnel small. It's just, and then they're changed to be small. But in this case, we have this shrapnel triangle. It's like a little square image, and with alpha, it makes it looks like just the triangle parts colored in. In this case, we're doing billboards. We don't do meshes. A billboard is just an image that's always facing the camera. And if I move up here, so duration, the whole thing lasts 2 seconds. It's all in sync with the rest. We have a start speed of about 46 meters per second. And the start size. So scale can be between 0.2 and 1. So it's a random, it'll generate a random scaling for each of these things between a 0.2 and a 1. So if I make them bigger, let's say go to 0.5 to 3, click play, you see how much bigger that they spawn out initially. They can have anywhere from a starting rotation of 0 to 360, local, plan away, blah, blah, blah. So we have, let's see, an emission, we shoot out 50 all at once, and then we're done. Shape, we're shooting out from a sphere. We have random points that we figure out on a sphere of size very, very small, and that's where all these particles will start from. The velocity will slow down with a damper and a drag of this. So if I click play, you see they kind of shoot out kind of fast, then they slow down toward the end. And then they fade out to alpha. They just start fading out. And if I turn on shrapnel small, it's all the settings are the same, except they're twice as fast. And their start size, I don't know if you remember the other one, but their max start size is half. So their min is the same, but they can only grow, potentially be half the size of the larger ones. And we still shoot out 50 over a small sphere. Velocity slows down at the same amount. Color drifts to alpha. Transparency at the same amount. And so if I turn this on, it'll just, these things will be twice as fast. Let me turn off the big ones. So that's what the little ones look like. And since they're moving twice as fast and they're alive for the same amount of time, they actually move twice the amount of distance. So you see it, they move out a lot farther. In the big shrapnel, let me put these back to 1 because they're so big that they're like obscuring the small ones. So there you go. That's why the small guys move out twice the distance of the large ones. So let me turn off the shrapnels and turn on the impact ring. And oh, looks like the impact ring is pretty big. I'll try to pause it. Ooh, try once more. Okay. The impact ring is this soft greenish, halo-y, soft object. So it's has a much quicker duration, just a half second. Start size of 3. Let's see what this thing is first off. So let's see what type of render we got. So it is a mesh. It's an explosion disc. It looks like disc. It's kind of, it's hard to see. It's a black wire frame. It's a very thin. Oh, here we go. So this is an interesting thing to talk about. This is viewing the mesh from the back, and it looks almost invisible. You can see the wire frame. This is viewing the mesh from the front. So every polygon only gets rendered on one face. So yes, in theory, there are two sides to each polygon, but it doesn't make sense to render both sides because like in 99% of the use cases, you'd only see one side. Like imagine in a game when you get your head of your character too close to a wall, the camera on the head, and it kind of cuts through the wall, and you can see behind the wall, and it's like invisible. You cut through the whole map or something. Most of the time, you'd never see behind the backside of an object, so there's no point in rendering it to camera because it's double the workload. So that's why whenever you see something that looks like it's invisible, you're looking at the back of a mesh, and that's what the normals of the mesh tell you. We'll get in talking a little bit of meshes later, but the vertices, triangles, there's UVs and there's normals, and UVs tell you how to place the 2D texture on the object, and the normals that come off the polygon, normals perpendicular angle, tell you which side of the polygon will be rendered to camera. It also says like how sharp the edges should be when the camera should. There's like smooth edging and hard edging, but in any case, the disk is just a flat disk thing, and so that must be it's angled toward the camera because I could see the disk here. It's this hazily ripply texture is placed around it, so the disk must be around. Actually, here it is. Here's the outer part. Here's the inner part. All right. Wonder if you could put on wireframe. Yeah, you can. So here's the disc oriented toward the camera. All right, you could tell with the black wireframe that it's the same object. And as I move the camera around this VFX, notice how the disc is always like pasted, glued to the camera. It's a very billboard effect. So with 3D geometry, um, it's doing a billboard effect, just like a 2D object would. So I guess it's this render alignment here, maybe. I'd have to look a little bit more. But I think it's this render alignment where it says facing instead of the world. Yeah, it's render alignment. It's interesting. So world is the 3D mesh placed at its word coordinates. Local is it. We'll get into local later. It's just like local orientations. As you rotate objects, they're like axis, they're X, Y, and Z becomes different than the world. And sometimes it's useful to use local instead of global or world. In this case, it's saying always just face the camera when you render. So the shader that's put on it has got this texture, this like ripply, like sound wave looking texture. It's this soft glowiness. So if I come down here, you see we have this albedo. And I don't know, let's see if I can, yeah, it's got a green undertone to it. So whatever color I place, it's got a greenish tint. So it's built, that's in there somewhere. But anyway, you saw how I changed the shader. Let me change it back to white, and let me see what else these colors are coming. I was expecting a type of emission, to be honest with you, but I guess it doesn't need emission because the render mode here is additive. It's not like opaque, a standard surface rendering. It's got this additive. So if I went to opaque, just so you know, this is what it would look like a basic solid coloring. But additive is done a lot with particles or things that you want to be like glowy or mystically or magical. So there must be, what's the initial, the start color is white. Let's see what the color over lifetime, here we go. Color over, in this case, this is like the opposite of the other ones, where the actual shader material was white, wasn't contributing any color tone, but it was saying, hey, I want you to be this additive type of color mixturing. But the actual color is appears to be coming through. So let me see, I make this red and red. So now we have this red glow. So let me switch it out to something else, maybe like a dark blue. And just note that since it's this gradient ramping thing, you got to do both of them. So this red that was way over here is really the one that's contributing. So if I take this color on the right and I turn it back to green, and we got this blue-green flowing through. If I just change this blue to like a white, just so you see like, oops, I deleted it. So if you ever delete one of these ticks, just, so anyway, white to green, right? And this is just saying this, the top part is like how the alpha is blending. I'll get to that one second. I'm going to wrap this up soon because I know I'm past 220. But just notice how this whole ramping coloring looks green. In fact, if I bring the alpha up, like there's very little white showing here, right? So just know that in this situation, um, this green part is, this right side coloring is actually having a lot more impact. And then on the top here, I can sway out the alphas and you can kind of see the impact. So you mess with this thing to get the look that you're going for. So anyway, I was happy to wrap up this VFX object. I'll do a lecture on Wednesday on the meshes and what have you. But it's past 220. And hang out if you have any questions. Otherwise, I'm going to stop recording and I'll get the video up.